everyone, my name is Dia Sebastian and I'm a part of S7EC SJCT Palai and I'm guided by Assistant Professor Juni M. George and my seminar topic is parallel hybrid electric propulsion in aircrafts. These are the table of contents I have included in this seminar discussion. So the first of all, I would like to introduce about it and the history behind the parallel hybrid aircrafts and also the motive and the types of fuels which have used by airlines, then types of aircrafts, the comparison between the hybrid and non-hybrid aircrafts, advantages and disadvantages, companies involved in the working of hybrid aircrafts, and the conclusion and the references I have referred for my seminar topic. So moving into the introduction, there are different types of engines and propulsion system which would work on the basis of combustion fuels and also electricity. When we come to the future, the hydrogen based. So actually, the period of or the era of World War was the time when people came to know about the importance of the airline industry, which causes to their daily lives, and more to that of movement of people to one place to another. They used for it for many other activities like photographies, bombing, reconnaissance, etc. So when we are thinking about a hybrid aircraft, it is a wide perspective. So I'm mainly focusing on uh, the cases of the technology behind or the technology which is used in the parallel combination with the jet engines. So moving into the jet engines, there are different types of jet engines. Specifically, there are five types of jet engines. They are turbojet, turbofan, turboprop, ramjet, and turboshaft. Then turbojet, turbofan, and turboprop are the three basic engines which is used in our airline industry, mainly in this period of time. And turboshaft, when compared to that of turbojet, turbofan, and turboprop, are not much used as the shaft using is much complicated when compared to that of other three. Then when we came to the ramjet, it is used in the case when we need to attain a supersonic speed range. Uh, Let us consider a case of a rocket. So the ramjet needs a basic another engine, maybe a turbojet or turbofan, to start to reach a basic level of speed, and after that ramjet could only start the engine and helps to attain a supersonic speed. Moving into the introduction part, I have started the introduction part from the Wright brothers, that is from 1903. The Wright brothers built the first aircraft, and which was a four-stroke engine. And after that, Louis Blanchard put forward his concept of single stick to control the whole aircraft by 1908. As I have told you, world wars were the great impact reasons of the airline industry. At the First World War in 1914, many military aircrafts were made which worked under the avgas or the help of avgases, and which is um, which is the combustion fuel mainly used in the case of a small aircraft. Okay, and at that period of time, under the Germany itself, they produced 20,000 and above military aircrafts by 1914 and 1915. And 1915, people started to make a metal frame for the aircraft for covering or protecting the aircraft and the pilot from bombing attacks. And by 1929, the Great Dornier Do-X was built, which helps to travel 169 passengers and traveled almost 1,700 kilometers. But the drawback was it was powered by 12 engines and 400 gallons of fuel for each hour. This drawbacks can is completely ignored by the invention of the jet engines by 1939. The studies were started from 1936 and the first successful turbojet was put forward by 1939 and further many turbojet engines came to the industry. Then the first innovative and the noticing one was the Boeing 707 and which worked on the basis of two engines. After that, Boeing itself put forward Boeing 747, which was a hybrid combination where the hybrid technologies era starts. That was a combination of one electric motor to that of a two combustion engine, which was done at 1970. At 1990, Airbus A380 was released with 15% lower fuel and operation cost when compared to that of Boeing aircraft which was released to that time. After that, Boeing 777 was released at successfully released at 2004 to the industry. The working behind this Boeing 777 was started from 1980s and still it's the world's most successful twin engine. And it uses the premium fuel for combustion. After the invention of turbojet engines, we came to use the jet fuels like the mixtures of kerosene. So, according to the quality of fuels, we could denote it as a premium fuel. It means the octane levels or the octane levels of the fuel would range from 90 to 95. If the octane levels are between 90 to 95, or the fuel is a premium fuel, the best performance of the aircrafts can be done or can be expected as an outcome. Okay, and it has also the folding wing tips in the case of Boeing 777. After that, Airbus A380 came to the industry. Uh, and it was done by 2021. It is the large passenger airline after the Boeing 747 into the airline industry. And when we compare to that of a Boeing 350 uh, and Boeing 380, Boeing 350 can go 1,000 kilometers more than that of a Airbus 380. And when we took consideration of the current state, in currently people are behind this hydrogen and hybrid aircraft. Yes, because it's much cost effective, efficient, and also better provides a better clean environment for our society. And the hybrid application could be expected by 2026 or completely expected by 2050, and the hydrogen application would be started by 2035. So what is the motive behind this parallel hybrid combination of aircraft? Yes, there is a great motive. Do you know that 2.5 percentage of the world's pollution or the world's global warming effects were put forward only by the airline industry? Yes, it's a true fact. And the 75 percentage of the carbon dioxide emissions of the airline industry could be cut down by the invention or by the application of the parallel hybrid aircraft, and the 90 percentage of the nitrogen oxide too by 2050. By 2050 means it is the expected period of the full accomplishment of the parallel hybrid aircraft into the aircraft industry. Okay, and the noise pollution which caused by aircraft could be reduced to a limit up to 65 percentage. And the other fact, you may know that the during the takeoff period, 70 percentage of the fuel is used. So when we are using an electric motor during the period of takeoff, we could say 70 percentage fuel only at that particular period of time. So uh, the fuel efficiency is much more in consideration or much effective in the case of parallel hybrid electric airplanes. And The propulsion is electrified and the designing freedom enlarges and the gas emissions are down by half. And there are many mission profiles or touch and go methods to make sure that we all know the importance of or to give and acknowledge to the people about the hybrid aircrafts. This graph was put forward by NASA according to the studies from 2020, and by 2050, we expect that the baseline production of carbon dioxide emission is reduced by 50% by by the good application of the parallel hybrid aircrafts on the airline industry. When we are discussing about different types of aircraft fuels, first we need to discuss about the combustion fuels. Yes, it's the current fuels which is used in the industry. They are the jet fuels, of gases. Jet fuels, as I have told you in the part of history, jet fuels is a mixture of hydrocarbons and based on unleaded kerosene or naphtha kerosene blend. So, as it is a mixture of a kerosene and contains hydrocarbons, it could lead to the cause of emissions like carbon dioxide and nitrogen, and also the particulate emissions too. And there are different ranges or there are different types of jet engines. The most used jet engines are the Jet A and Jet A1, which are the standardized international specifications for the jet engines. And when we can take in consideration about off gases, the off gases were mainly used till 1929, and in current condition, it is mainly used and for example, helicopters or smaller aircraft. Okay, and it's because its formulation is distinct from that of a conventional gasoline. Moving into the different types of sustainable fuels, there are biofuels, compressed natural gas, and liquefied natural gas. And further, we will discuss about the liquid hydrogen. Okay, and when we take in consideration of biofuels, biofuels are similar to that of a vegetable oil. Basically, it's related, and it's too similar because and their lubricity is very good for the aircraft. Even we use the synthetic fuels on the base on the replacing when we replace the combustion fuel, and when we take biofuels in the place of combustion fuels, we could reduce completely the carbon emissions. Okay, but still the condition of the nitrogen emissions could not be limited. Okay, so the importance of hydrogen is still, oh sorry, the importance of the electric or the hybrid aircraft still remain in its possession. And CNG and LNG, which is the short form, the actual abbreviated form is compressed natural gas and the liquefied natural gas, which is not currently used in the airline industry because it has one of the main disadvantages. It is a low specific energy. This low specific energy may overcome in the future. We could expect for that. It is basically a future aviation fuel. Then the next one is liquid hydrogen. When we came to know, or when I studied more about it, it's waiting a bright future because hydrogen is could completely avoid the nitrogen release by 100%, or and the carbon dioxide emissions is also can be reduced to a wonderful limit. And but in current state there is no much production of hydrogen is taking place, but people is came coming to know about its importance. People are trying to produce it from recent years, like using renewable energies like wind, solar power, etc. So types of aircrafts. I have put forward the types of aircraft on the basis of the connection between to that of electric motors, connection of a combustion fuel or a combustion fuel engine to that of an electric motor. There are parallel hybrid aircrafts, series hybrid aircrafts, fully electric aircrafts. In the case of fully electric aircrafts, it has only one electric motor. When we consider the case of a parallel one, the propeller has been directly coupled with electric motor and the last is coupled to that of engine. In the case of series, one generator is connected to engine and the propeller to that of an electric motor. Okay, and when we move into the next one, the more safety could be provided during the parallel a hybrid aircraft's condition because there is much power is provided. Like if we are moving to more slides, we could understand in detail. Okay, then the highest degree of hybridization could be produced by parallel hybrid aircraft when we compare to that of a fully and series aircrafts. Then the takeoff weight could be increased. Then what do you mean by takeoff weight? Takeoff weight is when we let us consider a case of Airbus A350 aircraft. The takeoff weight is 2,45,000 kilo and the landing weight is 1,82,500. Why is it different? Due to the effect of the gravity and also after takeoff, the fuel consumption is done to a limit. Okay, so the fuel is consumed to a limit. The weight would be reduced by that, and the effect of gravity would be high in the case of takeoff when we compare to that of a landing. So the takeoff weight could be increased to a limit in the case of parallel hybrid aircraft when we compare to that of a fully and a series hybrid aircraft. Weight limit is a mandatory thing in the case of a hybrid. In the case consider a electric motor in a connection, as electric motor has a disadvantage on it. But when we put forward a parallel one, it would provide a chance to increase the takeoff weight. So in order to compare between a hybrid and a non-hybrid aircraft, I have taken in consideration a non-hybrid aircraft engine, that is Boeing 777 aircraft engine GE90 engine, which is a part of GE9X series engine. This is the engine I have told you. There is two parts in the case of the GE9X 90 engine, that is high pressure region. This is the high pressure region and a lower pressure region. In between this region is where the combustion is happening. You could see a device over here. This is the EEC. EEC is known as electronic engine control, which controls and overlooks the working of engine. When the lower pressure region acquires 21% RPM, ignition happens. And you could see here 30 fuel nostrils. It starts to spray the fuel and then the combustion starts to happen. To increase in high pressure and low pressure turbines, airflow leads to increase the thrust. In the outer region, we could see 83% of thrust, and inside we could see 17% of the thrust in the case of this GE90 engine. When the lower pressure reaches 54%, it deactivates ignition system and 64% pneumatic pressure is cut off. Further, when the engine is completely on, the EEC provide instructions such that the twin is a part of twin engine, right? So the other engine get to know the information and it starts by the effective information provided by EEC. So for explaining about a hybrid aircraft, I have taken in consideration about the Rolls-Royce H3PS parallel hybrid aircraft, which was a test aircraft, which was released at 2021 by Rolls-Royce. And By H3PS, you may think that what is H3? The three H's constitute high power, high scalability, high powertrain. Actually, it's a four-seater test aircraft, and here we are parallelly connecting a electric motor, a 30 kilowatt electric motor to that of the hybrid engine Rotax 915 IS. This is the detailing about the engine. So this is the diagram which was put forward by Rolls-Royce company, and to show the parallel connection of the fuel and the electric engine to that of combustion engine, which would result in the working of propeller. The fuel used here is avgas with improved fuel efficiency and less emissions. As it is the case of a smaller aircraft, here we are using avgases. According to the, it's basically four per passengers test aircraft, right? So it's so small. So when we are moving to the higher ones, the fuel may change. And even though there is a chance for sustainable fuel usages too. Okay. And electric motors are used as a booster motors during takeoff and climb, and it also recharges the batteries during the flight. If one generator fails, other took control over the aircraft, but it stops charging the battery at the same time. If both generators are failed and the time is adequate, battery could take control over the aircraft. For the more information, I could explain it with a simplified diagram, a simplified working diagram. Okay. Here we could see two generators. Let us say it as a generator A and generator B. Generator A helps in the working of the engine, our hybrid engine, Rotax 915 IS. And it could be also worked under the condition of the combustion fuel of gas. There is two fuel pumps, fuel pump 1 and fuel pump 2 is provided for the basic working of Rotax engine. Here, there is an electric control unit with the two lanes to connect to that of generator A and generator B. Now you may be confused what is generator B is doing. Generator B is connected to that of backup battery. We could see that green colored battery over the right side. Yes, that is backup battery. It would be continuously charging the backup battery. The backup battery is took control over the avionics bus. Avionics bus constitute the light systems of the aircraft. Okay. So if let us consider a case when the generator A is off or the generator A is dead. So in such particular condition, generator B would take control over the working of Rotax 915 engine. So the lane B would be working, or the lane A would be handed over to that of generator B. And if let us consider both generators A and B is dead. Okay. In that particular condition, battery could be used to a particular period of time to maintain the working of Rotax 915 engine. And I forget to tell you that generator B, when generator B is working over the or working with the Rotax 915 engine, it would stop charging the battery. And when battery taken control over the working of Rotax 915 engine, the avionics bus would be no longer provided. Okay. So this is what Rotax 915 IS external picture. This is the expected powertrain timeline of a hybrid aircraft. By 2040 to 50, we are expecting a 200 plus seats and 5,000 plus nautical mile range traveling abilitized aircraft. And now, recently, by next year, we could attire 10 to 20 seats and 500 nautical mile range first commercial offering providing aircraft. This is the powertrain timeline which was put forward. It is an expected one put forward by ZeroAvia. So the companies involved in the working of parallel hybrid aircraft. That is, some of them are Airbus, Rolls-Royce, ZeroAvia, Embraer, Textron, Empire. When we take in consideration about Empire has released their electric eel, which is their recent hybrid aircraft, which was released by Empire in US, and they released it in California. And they also put forward another one, that is hybrid electric Grand Canyon flight, I think, which was done in 2022. Then another one in combination with that of Airbus, Rolls-Royce, and Siemens. That was the flight GWE Phoenix, which was a revolutionary hybrid aircraft for a particular period of time. And Zero Avia of US is working now on the basis of ZA600 hybrid aircraft, which is 10 to 20 seated, and which could be released by 2025. And do you know the fact that Zero Avia had put forward in 2017 $140 million investment for the hydrogen and combustion combination, and they are expecting that would be released by 2035. And also, their hydrogen electric prototype was released by Zero Avia by 2019, and they are expecting a full-sized one in this year, 2023. When we case about Emperor, they have put forward, they are working on the aircraft recently, the HAVS Airlander 10. And they could see some of these icons they have been using here. So when we are moving about the advantages, energy and cost efficient and short range aviation and transport aviation. In current state, it is much cost efficient and energy efficient for the short range. In the future, we could say that it is good and cost efficient and energy efficient in long range too. And another advantage is that its high efficiency power distribution and power sharing. The energy which is produced by electric motors is comparatively low when compared to that of a combustion fuel. But the power distribution and power sharing ability of electric motors are much advantageous for it to overcome such disadvantages. And another advantage is that distributed thrust control. An aircraft's propeller slipstreams, you could see the slipstreams over the propellers, okay, and which can significantly increase the airflow velocity behind the propeller disc, which will improve the aircraft performance in the flight. I think you know about what is thrust. It's inversely proportional to that of an air speed. And the next advantage is that power rich optimization. What do you mean by this power rich optimization? In the case of H3PS Rolls-Royce aircraft, we have seen there are two generators and a backup battery in consideration. It is a test aircraft, but in all these parallel hybrid aircrafts with parallelly connected to that of a electric motor provides rich power because and it provides much safety too, and enable new aero efficiencies. It is a much advantages which is put forward by this our parallel hybrid aircraft. In current situation, much safety cannot be provided by this combustion fuels when compared to that of a hybrid one. Okay, so much efficient changes cannot be found, or much design perspectives cannot be put down in the case of a aircraft, because its test cannot be done successfully, or its test cannot be done. Basically, it cannot be done in the case of a combustion fuel. There are many limitations, but these limitations are taken away by the involvement of an electric motor parallelly to it. That's why we could say new aero efficiencies are the advantages of one of the advantage of parallel hybrid aircraft. And the next one is low carbon propulsion. I have put down and show you the carbon emission, the estimated carbon emission graph put forward by NASA. Then they're moving into the disadvantages. The main disadvantage in current state is that it could travel only shorter routes, less number of passenger capability, less availability of skilled and qualified labors, and shorter routes. And these first two or the first three disadvantages can be overcome by the full implementation of high parallel aircrafts onto the airline industry, that is by 2050. And less availability of skilled and qualified laborers can be clarified to a limit by us engineers. Then low thrust, as I have told you about the distributive thrust control in the advantages section, the low thrust condition of an electric motor come to or overcome to a limit by this concept of a slipstreams over the propulsion system, which could effectively increase the thrust and reduce the airspeed. Moving into the conclusion, I would like to say that a better environment could be adopted by the simple implementation of the electric motor parallelly to that of an aircraft, right? A much safer one for the better future. And also, in the case of being an engineer, like it's a great chance to grab many opportunities behind these. So we can move forward and support these and combinational works, and we could work on it. And I think I think it was an interesting topic to discuss on. And these are the some of the reference I have referred for the discussion of seminar. And that's all. Thank you for your time.